So this is Eric Hess with the Encrypted Economy. Today we've got Sasa Milic on the show. She's one of three founders for API3 DAO, a young project that I was instantly drawn to when I heard about it. See, a few weeks ago they announced a partnership with the Open Bank Project, which is an open API middleware provider for the banking industry. This project is focused on enabling banks to send data directly to blockchain networks through the use of API3's Airnode that accesses first-party oracles. So what does this mean? Application developers can start prototyping blockchain solutions powered by open banking data. Use cases could include solutions like secure and decentralized databases for data verifications between banks and authorized third parties, and the bridging of banking and open banking data to DeFi, data marketplaces, and data unions. This partnership is focused very much on real-world cases. And there's been more announcements since. I was excited. I clipped the announcement and posted it on a Telegram group I am part of with a small group of lawyers that focus on crypto law. I simply asked, who knows anything about this project? I was lucky. Eric Dialis, an attorney in a large law firm, reached out to me privately and told me not only did he know something about it, but he had just given notice to join the project himself. Did I want an intro? I was like, yeah. See, I spent most of my career in capital markets as an attorney, but at times I also assumed very technical roles that blended law, and sometimes not even blending law, with networks, infrastructure, and even coding specs. I understand the importance that APIs play in pulling data for things like smart routing and algorithmic trading. In fact, even prior to meeting API3 and being introduced, I was already thinking about writing an article about why an API aggregator like Chainlink or Band was not a solution that could be uniformly applied across the blockchain-based ecosystem. I was troubled by how, in an ecosystem based on decentralized providers, that more attention wasn't being placed on how the aggregation of these links would insert statistical bias risk into the system and make it centralized. So I was really excited when Sasha agreed to join the podcast and explain. I hope you enjoy the podcast, and I highly recommend that you follow this project. At the very least, it's a barometer for something much bigger. And I think a debate that's going to need to be had. If you like this podcast, please review it, give us comments, and share it. And with that, I bring you the podcast with Sasha Milic from API3 DAO.
Welcome to the Encrypted Economy, where we look at the business of, regulation, and security for all things encrypted, digital assets, blockchain technology, privacy, and smart contracts. Hope you'll join us while we explore these forces that are shaping the economy. So this is Eric Hess with the Encrypted Economy, and today we're really excited to have Sasha Milic from API3 DAO on the podcast. I will let her do the introduction, but API3 DAO is, as you would imagine, also involves a decentralized autonomous organization, but more importantly, it's a direct connectivity to oracles, which is a very important service that I think is going to grow in importance as we start to progress toward Web3 and trying to integrate a lot of crypto projects with non-crypto based data providers. So Sasha, welcome to the show.
Thank you so much for having me, Eric.
So, and there's a few things we're going to be talking about today as well. They enter into some interesting projects, which Sasha is going to tell us about. Yeah, so before we even get going, I got to ask you a question. So today, you see, Dogecoin up to like 67 cents. You see a lot of this noise in the market. I mean, I will confess I was a believer in Doge at 5.5 cents and wrote it up to 35 and said, I'm out of here. So we were talking just about, as a startup, effectively, raising capital to get the operation going, in a market that has a lot of hype in it still. How do you view some of the, like the rise of, just for example, Dogecoin? Does it, how do you think of how it impacts your ability to raise funds? Does it hurt it because there's a distraction from fundamentals? Does it help it because the overall space is hot? Just kind of curious as to what your take on it all is.
That's such a good question. I feel like I should write notes because I have so many things I could say about that. But for one thing, I don't know if your audience is going to believe me or not, but I don't check prices very often. Usually I know there's been a big dip because someone in the team is talking about it, or we get a flood of people into our API3 Telegram complaining about our marketing efforts and whatnot. That's how I know there's been a dip. But I honestly, I've been interested in Bitcoin since 2017, but I got really interested in blockchain in general, especially applications that can be enabled with oracles and DeFi. I got into that like early 2019, like in the depths of the bear market, and I just thought the technology was extremely cool. So as much of a meme as it is, like I was initially interested because of the tech during a bear market. So like I can tell there's like chaos going on outside, but like I'm just kind of focused on my project. And what's funny, I was actually talking to someone about this earlier today, that it seems to me that developers, people building like not scammers, like people trying to build like legitimate blockchain projects, they're kind of waiting for a bear market. Like the bull market puts so much pressure on you to develop and develop quickly, and you have token holders that are on your back at all times. Like, and I'm starting to feel that way too. Like, I wouldn't mind like a small crash about now. But yeah, that's how I feel about it. Like, I think it's interesting just sociologically to kind of, people watching and seeing what's happening. But like, I'm personally not really affected by whether it's a bull market, whether it's a bear market. More people getting interested in crypto is great, because the first time I paid attention to Bitcoin was after the crash, because it made the news and I'm like, oh, maybe I should read about this thing. Yeah, I view, just so you know my bias, I'm a very optimistic person. So like even like the worst of crypto, I can see some good in it. So like all the crazy meme coins and whatnot, I'm like, well, it'll bring more eyes to the space, but I don't feel like it personally affects my day-to-day work life.
That's good. Yeah, I mean, honestly, in 2017, 2018, I was heavily involved in a crypto market as well as part owner and very involved with the management. The CEO would say, I can't wait till the market crashes so then we can really just get to work. That project was ill-fated. It didn't survive the crash. So in that case, it actually didn't matter. But I think the fact of the matter is that that's really when a lot of the real work, because I've heard it said before, and I believe it, it's, new tech, new innovation is often overvalued in the short term, but undervalued in the long term. And but I think your project in particular is very exciting. I heard about it. I actually went out to a Telegram group out large and I said, does anybody know about this project? Because it's fascinating. And then I actually met somebody on the legal side who's going to be working with your team, and he provided the introduction. So,
oh, Eric.
Yeah, Eric. Another Eric with an H, although, yeah, Eric with an H, not Eric with a C. It was Eric CH.
Yeah. I actually have one more comment, just because your question was like addressed a lot of things, also a lot of things that I don't get asked a lot in interviews. So just one other comment about my positive interpretation of what happens in the market. I think one really cool thing about crypto is it's usually seen as a negative thing. All these moon boys and people trying to figure out what's the next 100x, 500x. Like they're often seen in a bad light, but there's a positive to that, because it gives new projects like a huge chance and momentum that you pretty much don't see in any other industry. Like if someone was trying to replace Google or Facebook, like it doesn't really get momentum out in the real world. But in blockchain, if you come out with a new project, there's people that are just like nonstop, like what are the new projects? What are they doing? I want to get in early. And I've experienced that myself, because we got the first articles about API 3 immediately put us as a competitor to Chainlink. That wasn't our marketing strategy. That was just how reporters wrote about it. But that actually, it had a negative effect in some ways, but positively, because people are like, what's this new project? Like it's a low cap, whatever. I mean, I shouldn't be talking about price, but I'm just kind of talking about the mechanics of it. And
you're not hyping it. This podcast is not selling anything. We don't tell anybody to buy anything. No investment advice. It is about the tech. So
yeah. So in some ways, like, yeah, the moon boys tend to irritate builders in the space, but I'm like, it does create this environment where people are so open-minded to new projects, other than bag holders. But like most people are like, what's the new thing so I can get in early? And you don't really see that anywhere else in any other industry.
Well put. So you've given a little bit about your background. Let's go a little bit further back. Tell us a little bit about what you've been working on even before you joined API 3 DAO. And also, I often ask my guests for like one event in your life that helped shape your values or your worldview. So I'll let you run with that.
Which one should I answer first?
Whichever one you want.
Okay, I actually thought about the second one that you were asking me, just because I'm like, oh, I should have something good for this, because for the audience, like some of these questions I know beforehand, and I'm gonna have to kind of twist the question to answer it in a way I'd prefer, because it's not exactly one event, but it was just a way that I was raised that I now realize has a lot to do with my mentality, and especially the reason why I'm mentioning it is because it has a lot to do with why I'm interested in blockchain and crypto, and I was. Not to get into too many personal details, but I was born in the early 90s in Bosnia, and my family had to flee because of the war at the time. And so I was raised in Canada from the age of 5 by my parents, of course, but like a large community of Bosnians that had left for the same reason. So I only realized in adulthood that I was raised with a much different mentality than a lot of the people that I was raised, a lot of the kids that I went to school with, like especially when we moved to the suburbs. Like, I guess the best way I can explain it is like this no trust in the system, like whatever you want to call the system. Like my whole life, I've been hearing either implicitly or explicitly, like everyone's lying, all politicians are liars, everyone's trying to steal your money. Be very careful who you trust. Always keep an eye on your money because someone might take it. Like I said, some of these things were explicitly told to me, and some of them more implicit. Like, for example, I don't know if this is a common thing, but I know growing up, my mother would keep every single receipt and, like, at the end of the month, check with the bill to make sure, no one was taking our money. And I guess one way you could say it is like this very adversarial mindset, like everyone's an adversary, watch your back. And I realized, like, later in life, like a lot of the kids I went to school with weren't raised with this mentality. And I'm not saying it's a good or healthy mentality to have. It's just that's how I was raised. So just very much of a distrust of authority, systems, existing infrastructure. So why I bring that up is when I heard about Bitcoin and I heard about blockchain, like it made immediate sense to me. And it was and the value proposition was so profound and immediate for me. And I think... So let me just briefly tie that into something else. I've been paying attention to the types of people that are in crypto. So for one thing, you have to have a good understanding of the technology, which is like a huge, steep hill to climb. But there's this orthogonal dimension of like distrusting existing systems or just not having a lot of trust in existing monetary systems and whatnot. So I feel like the types of people in crypto have kind of both of these dimensions. And I'm not saying everyone was raised the same way I was, but I'm realizing as an adult that kind of mentality is definitely why I could see the value proposition and still do of blockchain and cryptocurrency and stuff like that.
Awesome. I actually did a lot of, I worked a lot within the system, and in many ways that, but I've always found a way to sort of, go on a orthogonal path, and that's what sort of led me to crypto. So I different experience, but in many ways drawn to it for the same reason.
And the second part to your question was about like my kind of what I was doing before crypto.
Yes.
Right? Okay. I'll try to keep it brief. In school, I studied computer science and statistics. I did a master's in computer science, and then I started a PhD. So I was kind of going in the direction of academia. So I took a lot of like very theoretical courses, did like research assistant things. And then started a PhD. I quit that. And then I just worked as a software engineer and a data scientist at a couple of different places, mostly in Toronto, where I am now. And I also worked a year in New York with Facebook as a software engineer. And then how I got into crypto is another thing, but I got really into crypto like early 2019, and I started just socializing with people like in New York who are also into crypto, and I kind of found myself consulting. Like it happened very organically because people could tell like I knew what I was talking about, and I had like an academic background. And then I ended up meeting the API 3 guys, so the rest of my team or the rest of the core team. Again, that's kind of a long story. I can get into it if you're interested. I met with them, and then I also kind of simultaneously started working at Gauntlet Networks, which is, I don't know if they describe themselves this way, but for listeners, it's like an auditing firm for DeFi, or at least that's a lot of what they do is that. Yeah, I guess if there's any other kind of details from that short explanation, you can ask.
Yeah, no, I think even Gauntlet is a impressive organization. It's run by Tarun Chitra. Did I pronounce that? Is Chitra, right? And he's done a lot with that organization, and I'm sure that was also a great way to sort of get some of his knowledge behind you as well. So there's a lot to cover on this episode, so we're gonna keep blowing through it, and you can we can cross reference some of the other things that kind of got you to where you are as part of that. So what API 3 addresses is Oracle connectivity, and one of the things that you have spoken and written about is this three-body problem. We're going to start out, because there's a lot to cover here, so we're going to start out with Oracle. What is an Oracle?
Okay, so I actually wrote notes. This is like the first interview I've ever prepared for.
Wow. I'm so honored that I was worthy of notes. Wow.
No, you had I could tell that you were very familiar with the project. I'm like, he clearly
and then I went back and asking you what an Oracle was. You're like, I wrote notes to tell people what an Oracle was? Eric, do you want me to tell you what crypto is? Crypto is, I'm just kidding. So anyway.
No. I could tell you prepared. So I'm like, maybe I should also prepare. This is a longer explanation than I usually do, just in case the audience doesn't have a computer background. So peer-to-peer networks existed before blockchain, so before Bitcoin. One example is BitTorrent, where people could, transfer files on a peer-to-peer network. Usually copyrighted things and whatnot. But blockchain is very different because we're dealing with the transference of money. And this is the stakes are much higher because everyone has an incentive, no matter how honest they are, everyone has an incentive to say, well, yeah, I have 100 Bitcoin in my account, I can send it to you. Like every single person in the network or using the network has the incentive to lie. So the thing that made Bitcoin different, and Bitcoin was what introduced this blockchain data structure, is it made sure that the network had a global state. So it wasn't like parts of the network could lie. Like there was a global state, and that was represented by this immutable blockchain, which is like a record of all transactions. Right. And since the Bitcoin, but blockchain networks in general are decentralized, every single node in the network needs to be able to validate a transaction. Since there's no central point of authority, every single person needs the capability to be able to validate a transaction. And just quickly, in case people don't know what validate a transaction means, in the Bitcoin network, in order for you to validate a transaction as a miner, you have to just make sure that person actually has the money that they say they do in their account. So that, in Ethereum, it's different because it's a general blockchain and validation requires a bit more work, but it's essentially the same idea. Like I want to make a transfer of money. I submit the transaction to Bitcoin so miners can add it to a block, but they first have to check that it's a valid transaction, that, I'm not sending you 100 Bitcoin when I have nothing in my account. So what I said was, the reason why I brought that up is every single node in the network needs to be able to do this. And in order to be able to do this, every single node needs access to the same data. So this means that the native data on the blockchain is, for those that do have a computer background, it's basically a mapping of address to data. So the data on the blockchain natively is just an address and what information is in that address. And that really boils down to, in practice, like what token does this person have? Essentially, that's the data on the blockchain. Like this person has this token. And I think that's the main reason why cryptocurrency is still the main use case and application of blockchain, is because the native data on the blockchain is ownership data, so value transfer. So what's commonly known as the Oracle problem is basically the nodes on the blockchain network don't have access to data outside of the network. So that's you can roughly consider that like any kind of API the blockchain doesn't have access to. Yeah. Do you have any questions? Because I have like a part 2 to this. Did anything I say not make sense so far?
No, keep going.
Oh, okay. So I have a part 2 because, right. So in summary, the Oracle problem is the data that's natively on the blockchain is like blockchain data. Like if you want to write a contract on, write a derivatives contract about assets off chain, like corn or gold, you can't do that because that information isn't on the blockchain. If you want to write an insurance contract, if my flight is late, then I get my money back. Like that's a very simple piece of code. That's just an if-else statement. If my flight is late, I get my money back. If not, I don't. But you don't actually have flight data, so you can't write this really simple, relatively elegant insurance contract because you don't have that data on the blockchain. I'm adding like a part 2 to this because someone actually asked in our API 3 Telegram after I had explained the Oracle problem in an interview. They were still unsure of it. So I actually have the question here. I still don't fully get why smart contracts need oracles. Why is it that smart contracts are not able to query APIs the same way regular apps can? Is it purely because smart contracts are completely reactive to data and they can't go out and make API calls themselves like a regular app running on a server? The person's basically asking, I still don't get why a smart contract can't just make an API call. And the answer I gave is that you could write a protocol, like you could write something like Ethereum that allows for nodes to make API calls. Like, sure, you can do that. But that is a bad idea for two main reasons. How would you, back to that concept of validation, like validation on Bitcoin is relatively simple. Do I have the money that I'm trying to transfer? Do I actually have that money if I'm going to transfer it? But how do you validate an API call? Especially if it's data that changes like every second, for example, like price data. Like how do you, once a node queries an API and every single node has to validate it, like what does that even mean? So the concept of validation is extremely tricky, if not like completely undefinable in this context. And then let's assume that you can validate an API call. So there's a blockchain protocol, it makes API calls, and then all the nodes validate it, whatever that means. Now, if you're making an API call, that's typically to like a central server or a relatively central computer network. So now you open up the blockchain to being able to be manipulated by other computers outside of the blockchain network. Like if an API call gets validated, like, okay, yes, this was the data received from this API. But if it's data manipulated by that API, now you have computers outside of the blockchain that can manipulate the blockchain. And how transactions are executed. The Oracle problem, I don't want it to sound like it's a problem with the blockchain, like the blockchain is faulty. This is actually a security feature. Like the blockchain is isolated, so other computers and other networks and other people can't mess with it. It's like it's isolated for security, but that makes it so that it's. But the flip side of that is it's hard to make more interesting blockchain applications with this inability to communicate with the outside world.
Right. And I might even edit some of this because I also want to kind of make sure I get this right. But sure. If you're putting that information on the blockchain and then it goes, let's say, whether it's proof of work, proof of stake, you have the validators, what now has to be done now? It changes the nature of what you're proving, right? And so you're basically, I mean, the whole idea of blockchain is to make it just, you're separating these with hashes, and it's just basically an ownership record. And if you're actually now trying to add more into that blockchain, it just presumably it takes more, it takes more gas, right? And it requires more work. And thus it just increases the cost as opposed to trying to make something slim and elegant. You're now bulking it with all these different components of it, which probably could be handled in like a side chain or a side, and not on the main net, arguably, right? Is that?
Yeah, there's a lot of problems with it. That's kind of why I posed it when I wrote this article. It's very short. When I pretty much posed it as like a thought experiment, like, think about a blockchain protocol that allows for API calls. Now think about what could possibly go wrong. And it's like a lot of things could go wrong.
Right.
Yeah.
Okay. Excellent. So the three body problem. What is the three body problem?
Let me get my notes. Where am I?
You know this because I've heard you answer this a bazillion times. Feel comfortable. You got it.
No, I do. But there's always like a couple of things that I wish I mentioned. So this is more like, let me just make sure I don't regret not saying something earlier.
So the encrypted economy is getting the fully refined Sasha Milic answer, right? Is that partially. we're getting the best, right?
Yes, partially refined. I'm never fully refined, unfortunately.
It's always a work in progress. Join the company.
Yeah. So one of the things, I think it was almost one of the thesis statements in the API 3 white paper, was that the data connectivity problem is a three-body problem. You have the blockchain, you have the data source, and then you have an oracle that transmits that data. Or at least that's how like the oracle problem is stated. But most, if not all, the existing oracle projects seem to treat it like a two-body problem. Like there's an oracle and there's a blockchain. and how do we connect them? And you kind of ignore where people are actually getting their data from. Like data isn't all equal. Like a simple example, in the original Chainlink white paper, they model the source of their data with with SRC. So like all the proofs, all the game theoretic things, everything is just talking about the data source as like this abstract SRC thing. It's never really addressed what it is. But I mean, if you're getting data from web APIs, or if you're getting data from like a central server, or you're getting crowdsourced data, these are all completely different and require like a specific solution depending on where the data actually comes from. So that's why we talk about kind of the three-body problem in the white paper, is that the Oracle problem is a three-body problem, and you can't kind of ignore the data source and treat it as a two-body problem.
And with that problem comes vulnerability, risk of Sybil attack. It creates a layer of expense and redundancy. It creates the middleman problem. I know I'm doing some of your work for you, but I'm calling back on you here. It creates a lack of transparency, and it creates something that you and I talked about that you thought was underappreciated, but I certainly appreciate, is the statistical bias nature of it. So do you want to touch on those points real quick, or?
Yeah. So I feel like just for your audience, I'll have to explain a bit about our project if I'm going to be kind of comparing.
All right, there you go. Let's.
I'll just focus on one aspect of the project, because I think we'll probably go into other aspects of it. One of the central ways that we designed API 3 was around having data sources themselves. So in our case, web APIs. Like we're focusing on web APIs as data sources, to have web API providers running their own oracles. Rather than this architecture that's existed before us, and with I want to say most, if not all, other Oracle projects, is where they have third-party nodes. So they'll have this like permissioned or unpermissioned network of nodes that gets data from some data source and then brings it to the blockchain. So our solution to that was kind of like I think Burak wrote a blog post about the Gordian knot. I don't know if you're familiar with that myth or story.
Oh, certainly familiar with the Gordian knot.
Yeah. So
I didn't read the blog post. I got to go back and read it now.
I can't remember the exact like myth. You might be able to remember it, but like basically like the solution, instead of untying this knot, this is some mythical story. One guy was like, we should just like cut it. Like there's no reason to untie this like incredibly complicated knot. It makes more sense just to cut it. And that's kind of our approach to the Oracle problem, is like there's so many additional problems that arise when you actually have a third-party layer of nodes getting data from a data source. You're actually making more problems. Best to just, get rid of it and get data sources to transmit data directly to the blockchain.
We'll include a link to the Gordian knot myth in the show notes.
Okay, cool. Yeah, there's other aspects to our project. It's not that simple, but that's the part that's relevant to what your question was, which is you were listing out the problems with having this additional layer, this layer of third-party oracles that gets data from a data source and puts it on the blockchain. So one huge issue that's overlooked a lot in networking is something called, well, not in blockchain, but in general outside of blockchain, is something called the Sybil attack problem, where you can't assume that in permissionless environments, you can't assume that every node in your network, every computer in your network represents a unique identity. It's very trivial in a network to run two computers and pretend to be the same person. So the reason why this is an issue with Oracle networks is like, how do you prevent one person pretending they're 10 different oracles and then manipulating data? Because the whole idea with these third-party Oracle solutions is you have all these different oracles getting data from a certain data source, and if you aggregate that data and most of them are telling the truth, you're probably fine. But like, how do you know that one person isn't just pretending to be, again, 10 different nodes? And then it makes it really easy to lie when you control all those nodes. And so that's something called the Sybil attack problem, and it's a big issue in networking and stuff like that. And we kind of deal with it. What's funny is we weren't even trying to solve this problem, but it kind of naturally gets solved in this architecture, because if an API provider is running a node, they have an identity off chain. And it's very simple to announce like, hey, I'm, on Twitter or on your documentation online to be like, hey, I'm running this node with this address. And now you have an identified, and it isn't like Bobby 93. It's like a company, so this isn't like a full-fledged solution to the Sybil attack problem, but it minimizes Sybil attacks significantly, because basically a Sybil attack in our architecture would mean that actual API provider businesses were colluding to manipulate a price, which, again, anything is possible, but it's just much, much less likely in this architecture than it is with anonymous nodes. So that's one thing. Sybil attacks, expensive, that's an obvious argument. If you're asking 10 nodes to get information from one source, you have to pay all of them. So cutting out that layer, obviously, is cheaper. And I don't even have to show the math to explain
right.
why. It's an additional attack surface. Like anytime you add a new architecture to the blockchain stack, it's a new attack surface. So anytime you add something, it really should be for a good reason. And I don't think anonymous third-party nodes is a reason for that. You're just adding an additional attack vector. Lack of transparency. With a lot of third-party node architectures, you don't know where people are getting their data from, which is a problem for a lot of reasons. And maybe we'll get into that when we talk about like statistical bias. And I think those are kind of the main ones. So it really is security and cost. Like getting the data provider who you trust implicitly. Like the way a lot of these third-party Oracle networks are structured is that you request third parties to get data from an API. So you're already like implicitly trusting the data source anyways. Might as well get them to run a node and get the data and give you the data themselves. And another kind of underrated thing, which I'm just glad you're mentioning, is the statistical bias thing. So when we're dealing with real value data, so not just binary, is the transaction valid or no? If we're dealing with aggregating prices, for example, how you do that is actually really tricky, because you would think, and this is what I thought like, well, clearly you'll come to consensus, because once you aggregate everything, it'll look like a nice normal distribution, and anyone who's lying is outside of a certain standard deviation. And it's a very simple consensus problem, but that turns out not to be the case at all, especially after I plotted, for example, Chainlink price feed distributions, and they're like multimodal. Some of them are like completely skewed. Sometimes there's a range of like $5 for like ETH or something. Like, and this has a lot to do with people getting data from different places. So the way that data aggregators like CoinGecko, CoinMarketCap, whatever, how they actually aggregate data is totally different. Like they don't look at the same exchanges. Some of them filter data with relatively sophisticated methods, like CoinMarketCap. They do something. They use machine learning to detect volume inflation, because exchanges are incentivized to lie about volume, so they can kind of raise in the ranks of exchanges. So what my point is, before I go off on a tangent, is that where you get your data from is extremely important, especially for prices, because people don't do the same things with data. And then you also have people reporting at different times, and price changes rapidly. So these were some of the things when I was actually kind of doing a statistical analysis of Chainlink price feeds, because I think they were the only price feeds that were running, so I could actually just scrape the data off the blockchain. One of the many great things about blockchain is totally transparent, so I don't have to ask you for data. I can just scrape it myself. Yeah, so these distributions were very strange. Nothing looked normal. And a lot has to do with people getting data from different places. So if people are getting data from different places, you're not naturally going to converge on one answer, one kind of like shelling point. It's not going to happen. That's one issue. I feel like I can go into others, but I'll let you talk.
No, and for the audience, and again, I'm just sort of reiterating it, but to the extent that you're developing your own statistical models and in how you collect this information, the only way that you can truly do it in a pure way is to run it directly to the Oracle yourself, because these weightings and these distributions may not be apparent to you, and you may be handicapping, you may be attributing certain weightings across different third-party providers that aggregate this information based on what you think the picture is, but in fact that picture could be completely incorrect, because they're not actually, they may have their own weighting, and some of that may not be readily apparent. So if you truly want to be able to create your own models based on that data, and you're relying on a third-party provider sitting in the middle, and you don't have any sense of how they're weighting that information, then your models are inherently going to be less accurate than somebody who's actually going out to them direct. And it's both obvious and non-obvious, but the impact of it, particularly if you're looking for precision in those models, it's very real.
Yeah, that was the other thing I was going to bring up. So thank you. And I don't mean to be picking on Chainlink. It's just that I was doing this sort of analysis on Oracle responses before I even started API 3. Like I was actually curious, like what do these distributions look like? And another thing I noticed with the Chainlink price feeds is that you can actually tell where people get their data from by doing like some sort of like a statistical fingerprint. So even if third parties aren't saying where they're getting their data from, you can actually tell by like doing some sort of like aggregated distribution stuff. This gets into super nitty gritty like stat stuff that I won't get into, but I can send a link after if you're interested. But it turns out that like there'll be like 4. So in the ETH USD Chainlink price feed, and it might have changed since I'd done this analysis. This is about 1.5 years ago because I don't want to like misrepresent their company. But when I did this 1.5 years ago, I could tell that like 4 oracles were getting it from like CoinMarketCap, and like 2 were getting it from like CoinGecko, and then there's like a couple that were getting it from completely different sources. So what you're saying about bias is that when you look at like one of these price feeds that are like, oh, it's a price feed that's fed by 30 different oracles. Like, wow, that's so robust, statistically robust. But if you actually look at it, it's like the skew is and the bias is hidden because there's certain data sources that are more readily available, cheaper. Like, again, we're talking about like financial incentives and blockchain. Like certain data sources are free, some aren't. So you're going to get data that's skewed towards certain sources. If no one has to report their source, or if it's not built into the protocol reporting where you're getting your data from, you're going to get skewed data because not all data is equally readily available and equally priced. It's going to be skewed in some way.
Right. Excellent. So, and the other thing that I think you noted is that it, as a benefit, is your solution would facilitate much greater scalability. Do you want to touch on that?
Scalability in terms of what?
I threw a curveball at you. I just noted it as an additional benefit was that you would have massive scalability in terms of being able to just integrate so many more data feeds. Yeah.
So I think that mostly would relate to our actual oracles. That's something I haven't touched on is the actual, like we call it Airnode. So it's the node that an API provider would run to provide data. So it's been designed to be, and let me know if you want to hear more details about this because I don't know how much I should go into tech. But
no, actually, it's a good segue. So maybe we should talk a bit about the Airnode of your project. Yeah, the serverless Oracle node designed for API providers. So.
Yeah, so I think Burak, one of my co-founders, it was his name, and I think it's a good name. So Airnode, it's to suggest that it's a really easy to run node. And the main reason for that is because it's stateless, and serverless. So what is your audience like a technical audience or?
So with my audience, typically I do some horizontal and then I do sort of a deep dive. So.
Okay. So stateless I guess it essentially means it doesn't have a database. Like it's something that it's like a program that only acts when you kind of ping it, and it doesn't need any kind of memory or any kind of a database. It's just something that kind of sits dormant, and then when it's pinged, it does its job, but it doesn't need any previous information to do its job. That's sort of like high level. And the reason why it's good is just because it's so, it's really like thin. It's not like a fat program that needs to be like maintained and checked. Like when something's serverless, it's just really easy to run and so much, it's much less prone to bugs. Like one of the biggest bugs with, or things that node operators deal with, like a node operator on Ethereum is like, when their database doesn't sync with the blockchain. Like that's mainly why Ethereum nodes, for example, aren't stateless, because you actually need a huge database to maintain like the history of the blockchain and whatnot. And sometimes those things get out of sync and it's just a pain in the ass. I haven't dealt with this personally, but people tell me, and I can imagine that's kind of an issue. As far as I know, other projects that build oracles, they sort of like build them on top of or build them like an Ethereum node. But the thing is, an Oracle, it doesn't need to have this huge history of the blockchain. It essentially doesn't need a database. All it needs to know is, hey, someone's requesting information. Let me give them that information. So it doesn't need to behave like a regular Ethereum node, for example, or any node in one of these general blockchains. It doesn't need a database. It can be built very simply, specifically for its purpose, which is, ping me and I'll give you the data you need. And I don't want to take credit for this. This is mostly Burak's design. So Burak, my co-founder, and I think it's such a simple idea. Like an Oracle doesn't need to do what an Ethereum node does. So we can kind of remove all this unnecessary code from an Oracle node, and that was kind of Burak's main design idea. Yeah. So it's stateless. So getting back to scalability, we're building something such that an API provider can deploy this in arguably minutes, depending on how complex their API is. But we're also building tools. So API providers, there's becoming this new standard called the Open API specifications, and it's a way that no matter what your architecture is, no matter what network protocol you're using, you can write. You can standardize your API interface, and we're building tooling. And we're almost done. That basically converts that into an Oracle specification. So basically, if you have an open API specification, you feed it into our converter, and you deploy a node on multiple cloud providers, and it's something that should be able to be done sometimes in 15 minutes. So that's when it comes to scalability. We don't have to, if an API provider wants to deploy an Airnode, it's something they can do immediately. And that's something you don't really see unless you've been working with API providers and Oracles. Like my co-founders were working on, we're working in the Oracle space for 2 years, specifically with API providers. And they realized this running a node isn't simple. Running a standard node in order to provide data as an Oracle is extremely complicated, and unfortunately, very few people actually understand the technology enough to run a node. So that was the inspiration behind Airnode. Because if we're going to have this large ecosystem of API providers providing data for the blockchain, this needs to be extremely simple and something that doesn't need to be maintained.
Right. And critically, anybody who's running the Airnode doesn't even need to know anything about blockchain, right? They just need to publish their API, and that's it, which is amazing. That's the way that we end up enriching the ecosystem with data from outside of the ecosystem. So
it's a good point. So that makes me want to mention that one of the things about our project, it isn't just a technical project. It has a lot to do with aligning our business model with the business model of API providers. Because it's easy to talk about data sources theoretically and API providers theoretically, but it's what are their actual business models? Why would they want to integrate with us? So a lot of our project is built around API provider business models, and my co-founders worked extensively with API providers, hundreds of them. So a lot of the project and the incentives are built around how do we make this as easy as possible and as desirable as possible for an API provider to join. So essentially, when we sell them this, it's hey, this is no effort on your part, but potentially additional revenue. It's pretty much upside, pretty much no downside. So it's been pretty relatively easy to sell to API providers because we've structured the project to appeal to their business model.
Let's talk about OpenBank, though.
Sure. Yeah, so this is one of our partnerships that, we're excited about all of them, but this one's kind of a recent one that we're really excited about. So OpenBank has been around for about 10 years, and they work on consulting banks for building APIs and also building API standards for banks so that people can interact with a bank other than having to go on a banking website or going to a physical bank. Sorry, that was a really bad explanation. I guess if anyone in your audience is familiar with an API, OpenBank works on making banking services accessible via an API interface, which is huge. We're the first blockchain project they're involved with. So I think they primarily serve, actually I know, they primarily serve fintech. So all these apps that want to do things budget recommendation or even money transfers and stuff like that, they actually need to interface with banks. So OpenAPI builds these things that are mostly used by fintech apps. Yeah, so I think they work. I have on my notes. They work with 40 different banks. I couldn't tell. I don't have listed some examples, but I think some European banks. And they also they have a couple of different wings of their project. So some of them work on open banking legislation to basically make it make it a legal requirement that some banks have to make their information and services interfaceable via an API. So yeah, I think anyone can probably understand why this is such a big deal. Like imagine the kinds of things you could enable if you could access your account via an API and even do it through the blockchain. Like one of the biggest issues with the blockchain, or what people see as an issue, is that again it's isolated and there's centralized on-ramps and off-ramps. But it would be really cool if like you could have an end-to-end blockchain application that takes money from your account, does stuff, puts it back in your account, or something that can integrate with the actual financial system outside of the blockchain. Like it's such a huge thing, and I don't think I can even comprehend like what that would imply. So we set up we have like a 10-year partnership with them, so it's a very long-term thing. And right now we're just like, earlier today, if you want like an example of what we're doing with them, we had a meeting where they were going through our technology, we were going through ours, and just understanding like how are we going to interface. Like this is the interface of your system, this is ours. Like how do we make it so that Airnodes can actually make these API calls with this open banking infrastructure.
Let's talk about staking. So, it was interesting. Certainly one of your co-founders, I know you've spoken about it as well, where staking makes sense and where a DAO makes sense. And I thought, I like the perspective on it, because there's just this assumption like, oh yeah, staking is a good way of getting people to invest in your company, and because they can make a return without really understanding what it is. And also, we'll talk about that next, when you want to do a DAO and when you actually don't want to do a DAO. In the lawyer community, we talk a lot about this notion of this DAO, this notion of decentralization as being sort of this thing people are trying to achieve. Like, oh, you're fully autonomous, or you're fully algorithmically managed. Like, what is fully algorithmically managed? Nothing's fully algorithmically managed. Maybe in 30 years when we're dancing with something from Terminator, okay, but it's not happening anytime soon. But back to staking. Where does staking make sense and where does it not make sense?
Yeah, a lot of big questions. So,
what is the meaning of life?
So I always like to go back to the fundamentals, and it might be because I took a lot of these theory courses, these computer science theory courses. So I always go back to the fundamentals. So staking started off with proof of stake, so an alternative for proof of work. And it's pretty much engineers a skin in the game kind of incentive model. So in a proof of stake network, instead of providing computational power, you put down money and you say, if I make an invalid transaction or I improperly mine a block, my stake gets slashed. And then if you do your job properly, you earn an interest on that stake. So it's like a direct skin in the game thing to incentivize good behavior. So I say that because staking is primarily a security mechanism. The reason why it should exist is if it's providing security for the network or the platform or whatever. But with the bull market, this is something I said in a recent interview or a panel. With the bull market, especially some of the questions in the API 3 Telegram, I get the sense that people think staking just means infinite amounts of money and zero risk. Or yield farming, it's just infinite money and there's no risk involved. That's why I go back to staking is a security mechanism. And our security model, well, it's kind of complex, but one element of it is an insurance pool. So if there is a data malfunction, you have about a week or two. It's a parameter, we might change it, but you have time to basically create an insurance claim. And then that is arbitrated by a decentralized arbitration layer on the blockchain, most likely Claros. So in order to have an insurance product, we have to actually have a pool of money. So that pool of money is provided by stakers, and the incentive for them to stake is because they earn inflationary rewards. There's a floating inflation rate, and that inflation is paid out to the staking pool. So basically, if you're staking, the inflation should cancel out because the staking pool earns the inflation, if that makes sense. So you're incentivized by that, but that stake could also get slashed. So going back to that security, staking being a security mechanism, this is our skin in the game security mechanism to ensure good governance and also to have an insurance pool. So the way that you govern, we're a DAO, so we're a decentrally governed project. The way that you get voting power is by staking. So the amount that you stake, you earn a proportional amount of voting power. And that means that anyone that's voting, anyone that's making proposals, anyone that's working for the DAO, their tokens are locked and they're directly participating in the risks and rewards of the system. So that's, I think I could get into more details, but that's the high level view of staking and why it's a security mechanism to provide insurance, but it's also a skin in the game mechanism to ensure good governance.
Right. And so what are you actually insuring against in API3 DAO?
Yeah, that's a good point. I get into this pretty detail in an article where I feel like maybe I should write something more formally, but I firmly believe that there always exists a data malfunction that just cannot be detected on chain. Just because there's no on-chain gold standard of like gold price or something. Like you're relying on oracles, so you really, I feel like I'm going off on a tangent, but there's just cases where you can get an oracle response that's faulty and you can't detect it at the moment that it occurs. So we just reason that insurance is the right approach. If you can't detect all potential data fault issues at the moment of occurrence, the best thing you can do is allow detection after occurrence and allow for insurance. And I think you're specifically asking, like, what are examples of this? Well, there's a lot of examples of DeFi hacks that dealt with like incorrect price data. So this is something that we're actually going to work out with some of the lawyers and what we call legal engineers on the team, is to actually outline like something akin to a legal document that says like, if such and such happens, this is a data malfunction, and this you can request an insurance claim for this. So the actual details still need to be ironed out. Yeah, it's essentially going to be a legal document that says, this is what counts as a faulty Oracle output, and this is what you can request an insurance.
And there was a situation where that happened with Chainlink, right? Relating to silver prices, was it?
Oh yeah, that was mentioned in our white paper. So I haven't read about that since I wrote about it in the white paper. But yeah, someone that was managing I think gold or silver data feed, like they have a data feed, an on-chain data feed for either gold or silver, but someone wrote the wrong ticker symbol and actually like the data feed that was supposed to be reporting silver started reporting gold or vice versa, one of those things. And that actually it wasn't, compared to a lot of DeFi hacks, it wasn't that expensive of an error. I think it was like 40,000. But Chainlink actually ended up paying them that money like afterwards. So we use that we use that example in our white paper to show that there's a precedence for this. Like there's a precedence for sort of like something like an insurance claim in the space. And it just makes sense, again, because you just can't detect all faulty information when it happens. Yeah.
Great. So now we'll go to the DAO structure. And I know in a recent article, one of your co-founders talked about this rush to DAOs. Like a lot of people are now just embracing the decentralized autonomous organization model. And we talked about this on the podcast with Mark Boyron with DYDX. We talked about DAOs. What's your views on the rush to create the DAOs? Does it make sense? Is the constraint it's causing on like even third-party audit services and the like, is that just a growing pain, or do you think it reflects some sort of something that's not really necessary in the marketplace?
Yeah, a lot of good points. Let me see if I can cover everything I want to say regarding that. So I think DAOs, I think any project that in the future, whatever that means in crypto, I think that every project that's a relatively complex project will be governed by a DAO. I think, and I also wrote an article about DAOs a little while ago, and I had a quote in there, but now I can't pull it up. But I was saying basically that with relatively simple protocols, and I don't want to call Bitcoin simple, but there's a couple of parameters in Bitcoin. Like all it does is transfer Bitcoin, and there are relatively few parameters. Like for example, one parameter is like a halving, like how often halvings happen. But there's not a lot of parameters in that protocol, and it does something relatively simple, which is just transfer money in the form of Bitcoin. But anytime you start getting more complicated, this is my opinion, but I just feel like it's really hard. The more complex a protocol, the more parameters that need to be tuned, the harder it is to get that perfect. So like the idea with a protocol is that it's immutable, like especially like for example an application on Ethereum, like it's immutable, it's on there. If you release some sort of a lending protocol, whatever on Ethereum, it's immutable. And I feel like any time like a protocol becomes more complex with more parameters, like I mentioned before, you're probably not going to perfectly engineer it. And you're going to encounter things that you didn't expect to happen, unknown unknowns. Like the more complex your protocol, the more likely it is that things are going to happen that it's not ready for. So I feel like every single project that's relatively complex, and nowadays pretty much all blockchain projects are quite complex and involve a lot of different parameters, a lot of different moving pieces. It's going to have to be governed. Like you're going to have to watch how the protocol evolves and how it behaves in the wild. And you're going to have to tweak a couple of things here and there. Like there's constantly tweaks happening to Ethereum in the form of EIPs. So I feel like if the project is going to continue evolving in a decentralized way, the tweaks to the protocol have to be governed in a decentralized way. So I think ultimately, like anything that's relatively a complex protocol needs to be governed decentrally. So in that sense, I think that DAOs are inevitable. However, it's in the blockchain space, it's always a question of implementation. I'm not suggesting that every DAO is actually useful or does the thing that it should do or is sufficiently decentralized. So probably a lot of the implementations right now of people rushing to DAOs probably aren't very well thought out and are just done kind of like a sugar coating on top of the protocol. But ultimately, I do think DAOs will become an essential, if not central element of the crypto space.
And in the context of API 3 DAO, what governance structures does it primarily manage?
Governance structure. So I guess I'll answer it the way I understood it, but if I don't, let me know. There's a couple of high level parameters of the system that are directly governable, and one of them is how much we need in the insurance pool. So the amount of inflation of the token is directly related to is a function of how much money we want staked in the pool. And that's a parameter that's governable. And who knows until we actually start the DAO, how often we'll need to change this. But that's, for example, a very major parameter of our system, like how much money is in the insurance pool. And that's going to be directly governable. But then we're planning to have like we've been calling it a fractal substructure. So by default, a DAO isn't very efficient because by default, the way a DAO works is someone makes a proposal and people vote on it. And as soon as it passes, like whatever code change needs to be made is implemented. So it's proposal, voting, passes or it doesn't pass. So this is actually can be quite inefficient. A very, very similar analogy to like direct democracy and the main kind of complaints about that by like political scientists, that it's just extremely inefficient. So we're going to have something called like sub-DAOs as well as teams. So essentially works the same way. They vote, they make proposals, but they have like the part that they governed is limited. So it's going to be like the technical sub-DAO, a marketing sub-DAO, a business development sub-DAO. So it's going to kind of be like a fractal thing.
It's similar to like when corporate boards get too large, they start to create committees, right?
I wouldn't know, but I believe you.
There's a lawyer in me, right? So I interpret everything through that lens. So going forward, so first of all, I guess, I asked you a lot of questions and you're probably like, oh my God, is he going to let up now? And we still haven't gone to the meaning of life. So I think it's like 42, but that's the point. We're working to that. That's our next. We're running out of time in this episode. So we're having Sasha to come back and she's going to tell us the meaning of life, start to finish. And, and no notes. So anyway, did I, in terms of the project, what else did I forget to, or did I not ask you that maybe I should have?
Yeah, it's there's a lot of moving pieces with the project, so it's hard. I'm like, was everything covered? I usually like make sure to mention 3 points when I try to cover it shortly. So first party API provider run oracles,
Check.
insured data feeds, we just covered
Check.
that, and decentralized governance.
Look, check. We got it. We covered it all. So
The kind of interplay is interesting, like how these things. We have a diagram in our white paper, and I also have like a long blog series that I highly recommend. Like if any of this was interesting to anyone listening and they're more interested in the project, I would recommend going to our Medium page, because we really create these kind of like bite-sized articles that get into like concepts and then how it all fits together. So I covered the main 3 things, but there's implications from those 3 design choices. And there's also like the way that they play together. There's more to cover, but I feel like the kind of high level overview, and anyone that would be interested in our project, I think has sufficient information to kind of know where to look for further information.
So it's the API 3 DAO Medium page. Also, the blog posts are also published on your site, I think, as well, right?
Yeah, I have my own Medium page. So yeah.
Oh, you have your own Medium page. So where, if people want to learn more about you, where can they find you?
I feel like I have kind of a limited internet profile, but I try publishing to Medium relatively often, and I'm planning on having something this week or next week. So that's just my name.medium.com. But if you search Sasha Milic Medium, you should find it. And I also have a Twitter account I created a couple months ago, because you need a Twitter account for working in crypto.
Apparently.
I don't post too often, but if anyone's interested, it's my name and 33 at the end of it.
Excellent. Okay. Well, listen, it was great to have you on the show. I enjoyed it a lot.
Guys,
And
I haven't talked this much all week.
Well, maybe that'll stand till the next podcast, right?
Yeah.
Or the next webinar.